So in this video, we're going to learn about the different types of triangles. So the purpose of this video is just to make you become familiar with the different types of triangles. So your only objective is that you can identify the triangles by its sides and angles. So different names of the triangles, and you probably have learned this ever since elementary school, but I want to have you remember what they may be. So triangles can be named by their angles. So there are four names by their angles. There's the acute triangle. So if I want to draw an acute triangle, it means all four angles, or all three angles, sorry, there's only three angles in a triangle, are acute. This angle, and this angle. If I want to draw a right triangle, that means I have a triangle with a right angle. And there's only one right angle. If there's an obtuse triangle, means I have an obtuse angle in my triangle. Sorry, it's a really bad triangle, but here's my obtuse angle. And then the other two are acute. Same with right, the other two are acute. And then an equiangular triangle means all the angles. You can notice in here we have the root word equal meaning equal. All the angles in the triangle are the same measure, like so. Alright, so triangles can be named by their angles. Triangles also have names by their sides. They're either going to be scalene, isosceles, or equilateral. Well, scalene means they are three different lengths. Alright, isosceles means there are two different lengths. Or we could say, let's put it this way, there are two congruent lengths. And then the third one. And then equilateral means all the sides congruent. So let's draw that out, what that might look like. So here, so these two are different lengths, and then I'm going to do 3 tick marks on the third side to show that that is different lengths. Isosceles looks something like this. Like that, and then you would have a side with different lengths. And then equilateral, use this tool, means all, I know it's not drawn to scale, but all the sides are the same length. So we have triangle names for the sides and triangle names for the angles. And yes, you need to know these very well without notes. One point I want to point out is that all triangles have two names. We can name a triangle by the angles and the triangle by the sides. And we're going to go through in class which names are possible and which ones are not. So you could have something like a scalene acute triangle, or right scalene triangle, or a isosceles obtuse triangle. Alright, so we're going to classify the triangle PQR and determine if it is a right triangle. Well, you learned from last unit that that we need two of these sides to be perpendicular. And if you kind of examine which ones look like, or which angle looks right, it'd be this one right here. So this side and this side need to be perpendicular. So remember, for it to be perpendicular, we need negative reciprocals of slopes. So we need to find the slopes of each of these lines. So in this one, it's -2 over 1. So -2 over 1 is one slope, which is -2. So that means this slope needs to be a positive 1/2, because the reciprocal of -2 is, or 2 is 1/2, and then it needs to be positive. And notice it goes up 1 over 2. So we know this is a right triangle. Now we just got to figure out the side lengths to see whether it's isosceles, scalene, or equilateral. You can already examine that it's not equilateral. We just need to know if it's isosceles or scalene. And if you want to save yourself time, you know this one right here, it's the shortest length. We need to know if this side, this side are equal lengths. If they're equal lengths, it's isosceles. If it's not, it is scalene. So to do that, way back in Unit 1, you learned about the distance formula. So we're going to use this distance formula right here. So we have our points. So we're going to plug in. Grab my pen. So let's find the length of PQ. So PQ equals the square root. Alright, and we have our two x coordinates. We're going to go 6 minus a negative 1 squared plus, sorry, that is a square. And then we have 3 minus 2 squared. Alright, now you gotta figure out what our inside equals. Alright, so you have the square root. This turns into a plus 7. 7 squared is 49. This is 1 plus 1 equals the square root of 50. And the square root of 50, it's probably approximately 7.1. Alright, so now let's do the length of QO. Alright, QO. So square root. We have 6 minus 0, which is just 6 squared. And 3 minus 0 is 3 squared. Add those together, you get 36. Again, I'm just using the formula. Alright, so you have the square root. 36 plus 9, which equals the square root of 45, which is not the same length. So that tells me this is scalene. Square root of 45 would be 6 point something, not the square root of 50. So this is a scalene right triangle. Alright, so remember all triangles have two names. So like this one right here, this would be obtuse, because you see the obtuse angle in here. And then it is isosceles. The obtuse isosceles triangle. Where this one, we have all the sides the same, so this could be equal lateral. And notice the angles are acute. It'd be acute. And we're going to talk about this is also equal angular, but we'll talk about that in class tomorrow. Reminder to do your reflection so you get credit for watching this video.